quick sort, it is in divide and conquer application. The second thing is it is in place sorting algo, and the third thing is it is not a stable algo. Why? I'll let you know. And the fourth thing is it is most practically used sorting algo. Why it is not stable? Why it is not stable? Suppose if we are doing sorting for this kind of, there are two elements 10, so first time it will do sort like this AB, and the second time it will like 2. So we can say 10A 5 1 10B. Suppose if we have this element, so it will do sort like this. First it will do one time 10A 10B and 10B 10A. It means repeated. If there are two elements which are repeating, then the order get changed, so it's not stable. So now move ahead, how we are going to work on it. So first it is an first we need to do partition, and partition means select element and the given array into two parts. We need to convert one array, and we have one array and we need to do given array into two parts by partition algo. And how let's understand it. Suppose we have 25 15 75 1 64 30 23 55. So index number 1 2 3 4 5 6 7 8. So in this we choose one element which is called pivot element. Based on this we do the partition with the help of partition algo in two parts. And what is the role of pivot element? Suppose if 25th is pivot element, this is the first element initially, so it will come in between, and before that whatever elements are present should be less than that, and after that whatever elements are present should be more than that. It is like that, partition done like this. So we can say simply division take order of n time, because we are doing like this. Suppose if this is pivot element, so it should be in mid, and whatever elements are smaller than that, it should be from left hand side, and whatever elements are greater, it should be right hand side. So we have to do comparison, and so it will take order of n time, because what it is clear that first element will need to compare to every other element. So and after that there is no need to combine. That's why it takes constant time, because as we know, all before pivot element should be less, and after that it is greater. So this is called the partition algo. And the thing is that random quick sort is also there and what is quick sort and what is random quick sort, what is the difference between them. In random quick sort, either choose first or last or middle element as pivot element. It can be anything, first, last or middle. When we choose like this as a pivot element, then this is called random quick sort. But only quick sort means that the first element choose as a pivot element. First element choose as a pivot element. This is the difference between random quick sort and quick sort. So let's write the partition. How we are going to do this? So write the algo partition a array, the first element and the last element, and initially we are supposing x as the pivot element we are supposing, and first we are assigning as a p. So here n-1 comparison will occur. We don't know it is less than, greater than, or it is the middle element. We are just assigning like that. So for we start with the second position, we are taking I as 1. So we start with the second position, j is equal to p plus 1, the second element, and j is less than equal to q. It will go up to last, and j plus plus. So here we do comparison. If aj is less than equal to x, second element, first element we assign as a pivot element, we are supposing, after that we are just doing comparison. Then we are starting comparison with the second element. It is less than equal to x or not. So if it is less than equal to x, it means it is less than equal to the first element, which is because we suppose x as a first element. So then what will we do? We increment I is equal to I plus 1 if it is less than, and we swap ai with aj because it is less than. Otherwise, what we will swap? We will swap ai with a p. Here we are swapping ith, it means ith element, not jth, ith element with aj if it is less than that pivot element. Otherwise we are swapping it with the pivot element, and it will return I. So this is called the partition algo, which we are going to use in the quick sort. And here, because we are comparing every time, so n-1 comparison will occur because we need to compare it with every element, and here also we are comparing. So, and this also n-1 comparison will occur. So this is the simple quick sort.